This is going to be what you will be doing in lab 14, the last lab for the course. And it's about pipeline design. So we're going to create a template to design a pipeline. The major thing we want to find here is the compressor you need to boost the compress the gas from station to station. So we're going to work on a problem. So I've created a problem which we're going to use to construct this template. So we want to compress gas. We want to compress, this is the flow rate, 500,000 mega standard cubic feet per day. We want to use X70 pipe, so which means the minimum yield stress is going to be 70,000 psi, specified minimum yield stress. Then the outside diameter is 30 inches. Now the maximum operating pressure means the pipeline, the gas must be at that pressure in the gas. So when the gas is moving from one station to the other, the pressure is going to drop below 1,000. So when it gets to the compression station, then you're going to boost the pressure back to 1,000. So it's going to be always, you want the gas to always be boosted to 1,000 psi. So that's the maximum operating pressure. And the operating temperature is 60, I think it's 60, yeah, 60 Fahrenheit. The specific gravity is 0.61. Now, we want to apply coating to the inside diameter, inside pipe. Now, this is to reduce friction. Usually, you can coat the inside of the pipe. So, we're going to coat 1/16 inch of enamel to coat the inside. So now we want to find the minimum thickness, the compression ratio, and the brake horsepower. So let's open the template. So there's the template. So I've already filled in okay, so let's see. I have 1,000 psi, that's the maximum operating pressure. I have 60 Fahrenheit. I have 30 inches. Minimum yield stress 70,000. Oh, specific gravity is 0.61. 0.61. 0.61. Okay. Now I'm changing the miles to 58 miles. Now, because we are pumping from station to station, there's only going to be one stage. We are using one stage compressor. So your problem is you just put one there. It's always going to be one. Now, we want to lay this pipe in class location 2. I think it's specified in the problem. Then it's 500 million. So because this one is in million, so I just put 500 there. I said 200,000 mega, so that's 500,000 mega, so that's 500 million. That's the flow rate. The pipe roughness is 0.006. We're not going to use that in calculation, but we're going to use that to find the Moody friction factor, which is that. I'll show you just in a bit. Now, let me recalculate the Z, because I changed the specific gravity to 0.61. Then this is the coating, 0.06625. That's I'm applying enamel coating of 0.0625 inches. So let me first go find the Z. The pressure is 1000, temperature is 60, and specific gravity is 0.61. So Bilbex 1000. This 0.61. 000. Okay, good. So if I look 0.8415. Go back to my template. Special. Okay, so that's my compressibility factor. This thickness is given. Now this one, so in this input, there are two things you have to go look for. The Z, using the Bilbex, and the Moody factor. The factor. Now I'm going to show you the chart. So what you need for that is just the roughness. So this is going to be the friction factor for this pipe roughness, 0.0006. Let's see how you got that. Now if I scroll, now to enjoy this, it's better to print it out and use a ruler too. Now I'm going to look at 0.006, which is that. So I'm going to trace it to the left. Now wait, I have one that let me upload. I'm going to upload one that's going to show you. Okay, I'll do that later on. So if I trace 0.006 from the right, I trace it 0006, I trace it to the left. I'm going to read here 0.0175. Okay, so that's the friction factor. Let me go back to my template. So I got that. So now let's go to the calculation. Always start with the temperature. So that's going to be in Rankine equals temperature plus 460. Okay. Next thing, the stress factor. Okay, the stress factor, that's what you need to find the thickness of the pipe, which is Fs. So that's Fs in this formula there. So what you're going to do again is, I have the table here. The stress factor depends on this class location. So I'm going to create what? We use lookup equals lookup. I'm going to look up what? My class location. Where is it? Class location, which is this C17. Then comma, it's going to find it where? I already named this table here. You have three tables in this template. The class location. So I'm going to highlight the class location. I already named it location. It's supposed to write the location there. No, okay, because I didn't highlight it. Okay. My mouse is always misbehaving, so. So I have to start over again. Where is it? I'm reading C7, C17. That's what I'm reading. Then let me type location because I already named it location. LO. I'm reading it from location. Then I think I named this Fs. So it's going to give me the value of Fs. That's the name. Okay. Oh, I have too many brackets. Oh, I didn't name it. Okay, so this is what I'm going to do. I'm going to name this. I'm going to name it. Oh, I already named it location, see, on the left. Then I'm going to, from here to here, I already named it FS, so what's the problem? So let me see again. Oh, it's my lookup. That's too many O's. Okay, lookup. Okay, lookup F C17 location FS. He found 0.6 because it's location 2. Okay. The next thing is power factor. That's what you need to find the brake horsepower. That's the F here, the capital F. So it's also another lookup there. Equals lookup. Lookup. Open the bracket. I'm going to look up. It depends on the number of stages. Actually, for this pipeline, I don't need it because I know it's going to be one. I'm using only one stage, but just okay. I didn't name that stage. Okay, it's going to look up there. Now, what is it going to look up first? It's going to look up where I put the stage. It's going to let me start over again because I don't want you to get confused. So it's going to be equals. Okay, you know what? Let me name this from here to here. I'm going to name it stage. The way you name it, you highlight all the numbers. You come to the left here where you see you highlight. Then you type the name you want. I'm calling it stage. Then you enter. Then this number, I'm going to, from here to here, I'm going to call it, that's the factor, BHP. I'm going to call it BHP factor. I enter. Okay. So now let's use the lookup. It starts to be 1 because I'm using, it's going to be stage, only one stage. Equals look up. Where is it going to read the stage? Number of stages. It's going to read it here. C16. Then comma. It's going to look that inside stage. Once you find that inside stage, it's going to return my PHP factor. I close. Okay, so you see it's 1 there. Now the next thing here is what? They calculate the pipe thickness, calculated pipe thickness. So we're going to use this formula here. So let's put the formula equals the pressure, which is 1000. I click on that. Multiply by what? The outside diameter, which is 30 inches, which is where here. Okay. Divided by 2 slash 2 slash that's the minimum yield strength, which is 70,000. Then slash what? FS. That's what where I said. That's this. C27. So that's the pipe thickness. Now we are going to do something in this template. we're going to be picking up from the manufacturer, which doesn't supply. Because if we want this thickness, it means we have to customize a request for customized thickness. But we're going to choose from the manufacturer's available thicknesses, which are in this table. They are all in 1/16th, 1/16 increment. Okay. So let's see, the next available one should go be 0.357. So the next available one should be 0.375. So the way we do that in Excel, I want to write a function to just pick the next available. The function we're going to be using is called ceiling. Ceiling equals ceiling. I want to seal it to what? Ceiling. See ceiling. I open the bracket. What do I want to seal? What I just calculated here. I click on that. I want to seal it to the nearest 1/16. So I put comma. 1/16 is 0.0625. Then I close it. You should be able to write 0.375. Okay, see? Okay, 0.375. So that's also inches. Okay. So we are learning more functions. So we're going to select 0.375 from the manufacturer. After I select that, I'm going to coat. I'm going to apply coating. So I'm going to coat it with another 0.0625 inches. So that's going to add to the thickness. So the inside diameter of the pipe now will be what? Equals the outside diameter, which is, I'm going to click on that, 30 minus 2 multiplied by what? The thickness, which is 0.375. I click on that, minus another 2 multiplied by the coating. I click on the coating. I close the bracket. No, did I open it? I didn't open any bracket, so that's it. So now the inside diameter is now 29.125 inches. Okay. So that's what I'm going to use in my calculation to calculate the pressure at the end of the station after 58 miles. So now that's the pressure there. That's what I want to put here, downstream pressure. So let's put that in the Excel. Equals. So square root SQRT. I open the bracket. P1 squared. P1. That's the maximum operating pressure. I click on that. Shift 6 to minus. Let me put everything there in the bracket because it's a long thing. I open a bracket. The first thing is 2.25.2, 25.2 multiplied by the friction factor, Moody. So I'm going to click on that. C22 multiplied by what next? Z. So I click on Z. Then multiply by let's see the formula. T, temperature, of course in Rankine, which is this, multiplied by the length. That's the distance between the stations. I think 58 miles. We have to convert 58 miles to feet. So I click on that. Then I multiply by 5280. That will convert it to feet. 5280. Okay. Then after that, what else? Now I multiply by gamma, the specific gravity, multiply by specific gravity, which is this. Then multiply by square of the flow rate in million, so which is 500. I click on the flow rate, shift to power 2, cap 2. Okay. Then slash, I divide now by what? Inside diameter to power 5, which is what I calculated here. C31, 29.1. Shift 6, 5 to power 5. I close my bracket. Then I close the square root bracket. Wow, good. So the pressure will drop to 754, about 755 psi. So it means my compressor needs to boost it by what fraction? That's the pressure ratio. That's the next thing there. Stage compression ratio equals. That should be, I'm boosting it to back to 1000. 1000, which is the maximum operation, slash whatever I calculate here. So my compression ratio is 1.32. That's what I will need to find my BHP, the brake horsepower. So equals 22 multiplied by compression ratio, which is this, then multiply by number of stages is 1, but I'm just gonna click on it here. Although you might not, the fraction is also, the factor is also going to be 1. Then again multiply by flow rate in million, so 500. I'm going to click on that. Then multiply by the last thing, factor, which is going to be 1, which is F here. So that's my horsepower there, 14,570. Okay. And that's just what you need to do. So all the answers are here. That's the BHP I asked for, the minimum pipe thickness. The calculated one is 0.35, but the one you're going to select is 0.375. That's the pipe thickness. The minimum is 0.357, but the selection is 0.375. Then I also asked for the compression ratio, which is 1.32. That's all what you need for this lab.